Thank you guys so much for having me. Patty Bloom, assistant professor and transplant hepatologist here. And I am definitely a newbie to the M Health digital health space. So I was particularly excited to be invited to talk to this group because I genuinely want to hear your thoughts, comments, questions, suggestions that you have about where I should be taking this next. What I'll be talking about is an algorithm that I created to analyze speech data to recognize hepatic encephalopathy, which is a complication of cirrhosis that's characterized by mental status changes, as it says here in the title. So I do have some disclosures. They're not relevant to today's talk. So I'm going to talk for 30 minutes to make sure we have plenty of time for discussions and questions. Um, I'm going to divide the talk into basically 10 minutes per each of these categories. So I want to give you guys some background on what hepatic encephalopathy is, what is the problem I'm trying to solve with my intervention. Then I'm going to talk about how we developed the speech analysis algorithm that we have currently. And then now I am currently developing the mobile app. And so I'll spend the last 10 minutes talking about what that's been like and hopefully be able to get some ideas from you guys on that part. So as I understood from Victoria and Danielle, I think the audience today, and I'm seeing from the chat also, is kind of a mix of some MD, some not MD, some nurses, but I know, and I think also a range of clinical backgrounds. So I will just bear with me as I describe a little bit of the background of what hepatic encephalopathy is, just so you know what disease state I'm working in. So the patients I treat have liver cirrhosis. So the picture on the left is a normal liver, and liver cirrhosis is the final destination of all chronic liver diseases. So whether it's fatty
Um,
liver disease, alcohol, viruses, you name it as the
um,
cause of
ik
the.
heb deze e-mail.
Oh, there we go. Sorry, I thought there was a question already. So yeah, cirrhosis is that kind of end stage of liver scarring from any of those conditions. And patients with liver cirrhosis end up eventually developing signs of liver failure when the liver isn't functioning very well. And one of those manifestations of liver failure is called hepatic encephalopathy, which is a mouthful. My husband's not in medicine. And even though I've been doing research on this for like 10 years, he still can't say hepatic encephalopathy. So everyone just calls it HE for short. And there's quite a range of manifestations of HE, all the way from really mild symptoms of just kind of mild confusion, short attention span, irritability, mood issues, all the way up to grade 4, which are people who are comatose. You know, they're in the ICU requiring a breathing tube and intubation because they're really so altered. Um, the natural history of this condition is that anyone who has cirrhosis can start to show symptoms of encephalopathy. Some of the risk factors for HE are at the bottom here. So liver dysfunction, malnutrition, needing to be on psychiatric medications, being frail, not having a lot of muscle mass. Those are a lot of the risk factors. And for a lot of folks, they initially bounce to this middle stage called covert or minimal HE, where they have minimal symptoms. But then at any moment in time, they can bump up to the top of this pyramid and just suddenly have really an overt or severe presentation that requires them coming into the hospital. This condition is associated with poor quality of life. These patients have frequent falls, car crashes. So we recommend that anyone with HE doesn't drive, which, I mean, just imagine your daily life without driving. It's very limiting in terms of what you can do. And folks have to stop working, stop taking care of their families. And so it leads to a lot of disability hospitalizations and ultimately can lead to death. And some of these patients are, these are like young people in some cases. I have patients in their 30s, 40s, 50s who are just really crippled by this condition. And only 2% of people with HE end up being a candidate for liver transplant, which is the only cure for the condition. So they're just living with this for a long time. So there are at least 500,000 Americans right now who have HE. And then obviously that number increases a lot if you think about the global burden of this disease. So there are a lot of people who are out there suffering with this confusion, short attention span, personality changes, sleep disturbance, and then much worse, hospitalizations. Um, and so this comes to the problem that I'm trying to solve in our clinical practice, which is kind of actually two separate problems. Number one is that we do not currently have a good way in clinic to diagnose the early stages of this disease. So we right now are just kind of guessing if people have it or not when it's at the early stages. And we're probably missing quite a lot of people who are at the early stages of HE and not treating them. And if we did start treating them at this early stage, we could reduce symptoms and we could prevent them from progressing to those later stages where they get hospitalized. So that's the first problem I'm hoping to address. The second problem is even for people who we know have a history of this HE problem, we don't have a good way of tracking them at home. We're dependent on them having a caregiver to reach out with us when they're having worsening symptoms, worsening confusion. But we don't have any clear way outside of that to track how they're doing. And if we did have a good way of tracking their symptoms as an outpatient, we could actually titrate their medications better as an outpatient and potentially prevent hospitalizations for worsening symptoms. So you may be wondering, my goodness, people have had cirrhosis for a long time and they've had this HE thing for a long time. Why has this problem not already been solved? Like what have we already been doing? And there are some current tools out there that help us diagnose HE and help track it. It's just, I'll summarize the tools we currently have, no one uses because they're either really cumbersome, they take very long to perform, and so they're not realistic for an actual real world clinic to do. Or they're very expensive, they require expertise. So just to start with the first one, electroencephalogram, I think a lot of you know this. That's the one where they have to put the stickies, the little sensors all over the head. I mean, it takes a long time to do, long time to perform, requires an expert to analyze it. And it's just not really practical for an actual outpatient hepatology clinic where I have 15 minutes to talk to someone with decompensated cirrhosis. Psychometric HE score is a pencil and paper test that, again, takes like 15 to 20 minutes to do. And so that's also just not very practical. Animal naming test is where people name as many animals as they can in 60 seconds. It is quick, but it hasn't yet actually been validated. And then I'll just skip the critical flicker frequency because that's also takes a long time, expensive, requires equipment. Encephalop, I'll show you, is basically, I saw there were a few psych people in the audience today. This is kind of a classic psychology test. It's a modified Stroop test where for one part of the test, the patient is supposed to read that word, but not say the color. So if you're looking at that word on the screen, they're supposed to say green, even though the color is blue. And then in some cases, they're supposed to say the color, but not read the word, which is it's like that cognitive dissonance that feels like an ice cream headache. And patients hate doing this test. They're always like, if I have them do it in the office, they're like, no, not that thing with the colors. We hate it. And we actually studied it here at University of Michigan. Like, we have this smartphone app that does this Stroop test. How many people will actually use it? And we went from 100 patients all the way down to 14 that actually were willing to download the app and do it at home. So, we think in large part this didn't really work because folks had to download the app themselves, they had to log in, and then they had to do this kind of long test that was really annoying to them. And so there were just too many barriers for them to actually test themselves and actually do the intervention. So we really need something now that is as easy as possible, is really intuitive to patients, and doesn't make them feel crummy while they're taking the test. And so we've thought a lot a few years ago about analyzing patients' speech as our diagnostic test. And we're not the first people to have thought about using speech as a diagnostic test. They've been investigating this in Alzheimer's disease, Parkinson's, and bipolar for, frankly, decades now. So we're behind the curve compared to those disease states. And actually, a speech app analyzing patient speech in congestive heart failure just got FDA breakthrough designation. So patients were kind of having more pauses in their speech when they were having an acute heart failure exacerbation. So we are following on the coattails of some other groups that have already been investigating this. The thought is that either in clinic or at home, patients could record a brief speech recording via a mobile app, and then that app would extract different categories of speech features from the recordings and would produce some kind of result to the patient and their provider that would then impact treatments. So some kind of alert saying, hey, you do have early stage HE, you should start therapy. Or for those who already have HE, hey, it's getting worse, you should increase your lactulose to prevent a hospitalization. So that's the thought behind this solution. And I came from Mass General about 3.5 years ago, and I did a study there, just an initial pilot study in about 80 patients with cirrhosis. And we found that that patients with hepatic encephalopathy do have slower speech, and that certain aspects of their speech correlate strongly with validated HE tests. And actually, for this journal, the Red Journal, they had me record someone speaking as slowly as someone with HE does. And I had my husband do it. And he was like, Patty, there's just like, I can't do this recording. It's so slow. Like, there's no way that people are actually speaking this slowly. And it really, it's really notable when people have this condition, their speech rate and other features of their speech really notably change as compared to patients who don't have it. So moving on to the second part of the talk, now that I've given you guys background about what this condition is and why we thought that speech might be an interesting diagnostic target, I'll talk to you now about the investigations we've done to try and develop an algorithm that predicts HE. So we just completed a study here at University of Michigan, and I had a collaborator also in Texas, where we aim to develop a speech algorithm that would, number one, help diagnose minimal hepatic encephalopathy. So that's the early stages of this condition. And then number two, it would also predict future overt encephalopathy, which is the severe manifestation that brings people into the hospital. So it was an opportunity to create a trial with a cute name. So the Hear Me trial, HE audio recording to detect minimal HE. We enrolled patients with cirrhosis and then also 50 controls with liver disease, but really early stage liver disease. They didn't have any significant scarring in their liver yet. And all the patients had to be fluent in English and have no other neurological diseases. And we enrolled in Michigan and Texas to try to get folks with different backgrounds and different accents, especially because, we know there's a variety of accents in Michigan and same thing in Texas as well. And so we wanted to make sure that whatever algorithm we created would have some, potentially external validity and work outside the state of Michigan. So what we did is we enrolled these 250 patients after their baseline visit, which was just right after their usual hepatology visit. We had them do a psychometric HE score, which is that 20-minute long test that's well validated to diagnose encephalopathy, but just isn't realistic to do in the real world outside of a research setting. And then we also audio recorded patients doing 3 different speech tasks, a picture description task, paragraph reading, and then the animal naming task. And then we also recorded a lot of basic clinical and health data, including how much people were drinking, which for people with liver disease is a really relevant thing. There's a lot of alcohol use in patients who have liver disease. And I'll just spoiler alert, the folks that we got largely actually weren't drinking anymore. So that's not a big factor for this group that we happened to enroll. And then we followed folks for 6 months. We repeated audio recordings over time and we tracked what was happening to them clinically. Importantly, we tracked if they developed one of those severe episodes of overt encephalopathy. And then we had these partners at Winterlight Labs. They are a group out of Toronto, Canada, that they have a really nice speech app already that allows you to just record that speech clip that you collected, and it automatically transcribes it and analyzes it according to their platform. I will just, and it records all of these variables, different tempo variables, acoustic, higher order, like the complexity of their speech and thought processes. Acoustic is talking about the actual sound wave, like the pitch of and the amplitude of someone's speech, and then tempo is how quick the speech is. So I'll just mention that Winterlight has their own proprietary speech app, but actually most of the variables that we were collecting, you are able to use widely available open source tools to automatically analyze speech. So, for example, like the rate of speech, I don't need to use Winterlight's tool to record rate of speech. There are open source tools that allow me to take a speech sample and automatically spit out what the speech rate is. So we enrolled 200 patients with cirrhosis and 50 controls. And here are some basic patient characteristics. The cirrhosis group was a little older. And we had roughly 50% men and women in the cirrhosis group. And a third of them roughly had alcohol as the cause of liver disease. About a third of them had fatty liver as the cause of liver disease. And then the other third was kind of a mix of different causes. And I'll just say that for the office recordings, they were fairly quick. For example, for the paragraph reading task, which I'll just cut to the chase and let you know, it was that was the best task in terms of performance in our various modeling schemes. The paragraph reading task, it only took 37 seconds for patients to perform. So that's really quick. That is something that you could imagine someone actually doing in a return visit in person, or you could imagine them doing it at home. It's something that perhaps even the medical assistant could do with the patient while they're rooming them. Just looking at speech rate alone, we found that in the blue dots, patients with cirrhosis who had no HE, they were really similar to the controls who didn't have cirrhosis. But then if you look at in the red and the yellow dots, those are patients with either minimal HE or they had prior overt HE. You can see that their speech was quite a bit slower than patients who didn't have HE. And then we did quite a bit of modeling that I'm happy to talk about, but I think it would probably make a lot of you guys fall asleep. But we did a lot of techniques to basically boil down 500 speech variables into what are the most important variables that identified minimal encephalopathy. And then we also looked at what clinical variables could be important, like age, how severe is their liver disease, which is what the MELD sodium evaluates. That's a marker of how severe the liver disease is. We also tried to see if patient sex or the region of the country they're from, what their accent was. We tried to put all of those things into a model and 5 variables ended up coming out as really important and very useful in a model that identifies minimal encephalopathy. The speech variables, the first one is speech rate. So just how quickly someone was speaking. This MFCC skewness 22, I know, very catchy name. That is an acoustic variable. So it gets at, again, kind of like the pitch and amplitude of people's voice. And then jitter is also a cute name for another acoustic variable. And we did a lot of different modeling techniques, and these variables just came up time and time again in each, different way we tried to model. And then age, also maybe not surprisingly, was significant, and the severity of liver disease was significant in predicting minimal AG. So all of these variables combined, they had a pretty high area under the receiver operating curve for predicting minimal HE. And just by comparison, 1 would have been a perfect area under the receiver operating curve. But then when you get to an AUC of 1, that's almost too perfect. It's like potentially overfit to the data. So I'm pretty happy with an AUC of 0.82. And then we also saw that same algorithm that identified minimal encephalopathy, it also predicted future overt encephalopathy with a concordance of 0.8, which is pretty good. Just to give you kind of a more specific, tangible example, patients who had a speech rate under 133 words per minute had a significantly shorter time to overt HE than if you had a speech rate over 133 words per minute. So speech rate was just one of the 5 variables we were using, but it's kind of the easiest to understand. So that's the one I use here. But we did really find that speech was doing a good job of predicting and identifying these important clinical outcomes. We also found out, importantly, that the recordings were feasible at home. So you may remember from the methods we used, we sent people home also with the app downloaded on their phone. And we found that home speech rate was also correlated with the office speech rate, and using the same predictive model on the home recordings, we were able to still identify minimal HE. So these audio recordings are feasible, it seems, at home. And the speech algorithm also seems to work in diverse settings. So speech rate, again, just to pick a specific example, was similar between the 2 sites, the one in Texas and the one in Michigan. And even though you can see the geography of origin, there were a bunch of different origins that were included in the study, and speech rate did not vary by the region of origin. So I know we all like to make fun of people from Texas, right, with their like slow Southern drawl, but it didn't make a difference if you were from Texas, or if you had a classic Texas accent, or if you had a Michigan accent. Although people from Michigan have told me that there is no accent. The way people from Michigan speak is the perfect way to speak. I've heard that before, but anyways, so it works in all groups. So conclusions from that part of that phase of this work is that even really brief audio recordings, just 37 seconds of reading a paragraph at home or in the office, is enough to identify minimal encephalopathy, and it does it as well as some traditional tests. Speech also predicts future overt encephalopathy, that severe outcome that we're trying to prevent. And it's a promising novel method for identifying people who are at risk of hepatic encephalopathy. So now I'm going to cruise into the last part of this talk, where I'm going to talk about, okay, now I have this algorithm. I have these 5 speech variables that when I combine them together, I'm able to tell if someone has early stage HE and they're at risk of future severe HE. Like, what do I do with that algorithm? How do I actually implement this into my practice? And some kind of mobile application obviously leapt to mind pretty early on. But things that were really high on my priority list are it needs to be just an incredibly simple implementation. Any single thing we ask these patients to do, we're going to have a steep drop off in involvement. Okay. So, even opening the phone, I feel like is like a step that you might get some drop off and people not interested. So needing to download an app and go into the app store, download it, that is going to be a problem for some people. When I'm in there in clinic with folks, they all forget their Apple ID password, and then we have to troubleshoot. And then the internet in clinic isn't great. And so they're like, I can't download it. And any of those issues just lead to challenges. Needing to remember a subject ID and a password is a major problem because you have to remember my patient population. These are folks who have a cognitive issue. That's like inherent to the problem that we're trying to solve. On average, they're also like generally men in their 50s and sometimes older and just aren't as like skilled with the phone necessarily. So it just needs to be very simple. Um, Also, in an ideal world, the data would need to connect to Epic. And I say that because we want their providers to get the information, right? It's great if the patient receives some feedback, but we really want the provider to also receive the data ultimately. And so whatever the tool is, whatever the app is, it should ideally connect into Epic so that it can show up in some kind of dashboard for providers or some kind of flow sheet. Um, and then there's this other question about, how are we going to actually incorporate
Mhm.
the recording of speech into practice?
Yes.
Ooh, oh yeah, okay. Are we gonna ask people to just record this in clinic? Are we gonna ask them to do it at home? And like, how would it exactly be incorporated into care? Like, if I am I going to be looking at the change in score over time, or am I going to pick like a cutoff of the score and say above this is good, below that is bad? All of those things are still up in the air, even though I have this algorithm. So Victoria and Danielle asked me to highlight some of the resources at Michigan that I've used. And so the first one I want to highlight is the Fast Pace program, or it's Fast Forward program with Fast Pace. And this was a really cool program. It was several weeks long, and I met with this group of people who were some of them were like me and just trying to develop an innovation, and then there were experts in the group giving us advice. And it was really focused on customer discovery, meaning like if I do create this app, who is it for? Like, am I designing this for patients to ultimately use and maybe purchase, or am I designing it for GI and hepatology practices to purchase and use? Is this the kind of thing that Epic would buy? And basically just trying to figure out who my target audience is and who am I trying to tailor this app to. As a clinician, I'm so focused on the patient and their caregivers, right? But this program really helped me to see the real world, which is that it's not just in order to get into the hands of the patients and the providers, it needs to pass through a lot of other hands first. And so we tried to figure that out. They also had me create a value proposition, which I have listed here, which basically states what the value added would be of my app if once we end up getting it created. So our mobile speech app will allow providers to identify and treat hepatic encephalopathy early, thus preventing 20% of symptoms and hospitalizations for HE, which would have a total savings of 5.2 billion. That's a conservative estimate across the US based on how much it costs to hospitalize these patients. So as part of that fast-paced program, I also created this stakeholder map, which is, I know, very busy, but it helped me to think through exactly how this app would be used and how all the potential stakeholders in the system interact with that app. So, the patient and the caregiver come into clinic, they're very motivated to feel better and to prevent further decompensating and problematic HE events. The hepatology clinic is motivated to provide excellent care, but also they're motivated to kind of maximize the clinic's efficiency. And then in the clinic, they're given the speech app, which helps diagnose minimal HE and also monitors HE as an outpatient. The hepatology provider and the hepatology nurse are obviously the ones interacting with the app and trying to explain what the app does to the patient. The nurse is probably going to be very involved in kind of looking at that data that comes in from the patient when they're at home. And some of the data that comes in might send people into the hospital if their symptoms are worsening. The data goes into the electronic medical record. And so, for that reason, the app would interact with the EMR. And then the insurer is paying for all of the things below. So they're a clear stakeholder because they're very motivated to try and prevent some of these very expensive hospitalizations for people with HE. So, actually going back here for a second. Oh, actually, you know what? I'm gonna keep moving because I remember I have it on the next slide. So there are also some regulatory considerations that I need to keep in mind. So this tool, this app, would ultimately be a diagnostic test that is being used to influence patient treatment. And so for that reason, would need to go through the Food and Drug Administration regulatory pathway. So ultimately, I would need to be, applying for an IDE or an investigative device application. And the output of this tool would supply diagnosis or prediction material to provider, and it would help them make a decision about treatment. And so therefore just needs to have that higher level of regulation. And also there is some sensitive data because this would be connected to the patient's chart. So would have to have, some patient identifiers connected with it. It also might potentially end up getting connected to the patient portal if it ended up being a part of Epic, and so therefore would need to be able to handle private patient information. So I still, after doing all this customer discovery in the fast-paced program, I still am not 100% sure who the best customer would be for this ultimate product. I've heard experts very convincingly tell me that it should be each of the different things that you see listed there. The EMR companies, insurance payers, GI divisions, or pharma. I think pharma is likely to pay for it, but I would probably be most interested in an EMR company buying it, like Epic, for example, because then it might be most easily incorporated into the app that some patients already have on their phone. So I'm curious to hear what others say about that. And a big learning point for me has been that, as a hepatologist, as a clinician, I've been so focused on the patient priorities this whole time and didn't realize that I would, in creating the app, I would need to also consider who's going to pay for it because they're going to be the ones that I'm ultimately trying to kind of sell this product to and convince them that it works and does what they want. So it's not just about what the physicians and patients want. Kathy, I see that you have your hand raised.
So I have an idea for you
Tell me.
to kind of reduce friction of implementing this. So there is baked within Epic, we don't have it with our instance of MyChart yet, a passive digital scribe that will be writing our notes in the future while we're sitting in our room. It's part of something called like Nuance. It's something by 3M, but it's baked into Epic. We'll get it eventually. And I don't see if there's a passive recording method for the physician voice. I don't see why there couldn't be a module for the patient voice. and then hopefully something that could be adaptable both in office and through the My U of M portal. And I think that would be awesome. And then you could, I don't know, I mean, you probably worked with Drew regarding like where the IP lies in this. And so you
Yes.
could just sell it to Epic for a lot of money.
That would be great. That is such a great idea. I had not thought of that, but you're right. Do you have any sense of when that would be coming to us?
I don't know, but I will find out through like the OCI meetings and stuff. But what I'm wondering is that if a use case like this could potentially speed it up. And also, I'm wondering, from our psychology colleagues that are here today, if a use case in psychology disease states could also like drive that need for the patient voice recording to be implemented into the technology.
Yeah, and I know that for a long time, there have been a couple people here working on bipolar disorder and speech, because I've chatted with them a few times, and that science is definitely farther along even than mine. So yeah, that's a great suggestion. I only really had a couple of slides left, which is to say that I've met a couple of times now with the Mobile Technologies Core and just gotten so many resources from them that are going to be very useful right now. Um, they've given me a list of potential requirements for the app, including things that I did not think of. So as a non-technology person, it didn't even occur to me some of the things that I would need to decide if I want it in the app or not. They've also given me suggestions for funding opportunities and also some language that could go into grants, for to apply for more money for the next steps in this project. Also, there's some iOS and Android app building services they've shared with me, connected me with U of M researchers who've developed apps, and also connected me with potential vendors who we at U of M have had good experience with before, which is great. Like that's really nice to be able to just connect with some groups that have already contracted with U of M and done a good job. I didn't mention it earlier, but the thing that I'm hoping to do is actually to have a mobile web application. So basically on a website. And I got this idea from a conversation with the Mobile Technologies Core, so that my patients would basically just receive an SMS text message, be able to click on a link, and it would bring them to the mobile interface. And they'd just be able to click record, and they'd be able to record their speech sample, and it would be done that way. So they wouldn't need to necessarily download something to their app. And then the last slide here is just that this month I actually finalized the speech model. So we kind of have the first version of what the product will be. And then I will, in the next few months, be meeting with different potential vendors, select the developer, and then hopefully this summer create the first version of the app. Meanwhile, applying for funding for a validation trial. And I already run a lot of trials in this space. And so I'm going to be incorporating this app into all of my ongoing research trials. And then, yeah, hopefully at the start of next year, we can run like a trial explicitly to validate this. So Aiden, I see you have a question.
Well, I was hoping to contribute to, I guess it is more of a comment than a question, but I suppose I wouldn't necessarily call it an answer because you might have more, but I was thinking about the questions that you were asking, and I thought I'd share some thoughts that I had going through this.
Please.
So the first thought I had in your presentation is that the sequelae or the outcome of encephalopathy and hepatic encephalopathy is going to be general cognitive dysfunction that's not specific to encephalopathy, right? I mean, I think that there may be some specific features. I'm not all that familiar with the pathophysiology of this all, but in essence, all the things that you were suggesting that are existing tools are general tools that are just applied in this case. Mm-hmm. And so I think putting a pin in that, the other thing is that you're proposing using another thing that would also be a general assessment, right? You have someone read something, and in that case, it's another very general tool. Again, your interest is in applying it in this case, but other people could use it in a variety of different ways to look at cognitive functioning, regardless of what the cause is. The specifics, though, may come in the algorithmic aspects of what it is that you're extracting and what is most useful for differentiating people with or without hepatic encephalopathy. And so in that case, what I'm getting to with this, and similar, this also comes up with the app aspect of it, of what part of what you're doing here is something that is very general and is not unique to what you're interested in versus what is unique and what would be specific to this use. And I think that has implications for how it gets implemented and the like. So for instance, you wouldn't want a different app for every possible cognitive impairment that someone could have, something secondary to or hepatic encephalopathy versus TBI versus MS or something like that, right? And so I think when talking to people who might want to purchase this, I think you want to be clear on what you're selling and whether you're selling the ability to record or something like that, or whether you're just saying, if you have the ability to record, I'll sell you an algorithm that helps with HE, for instance. I think, and depending on this, it sort of depends on how, like, you want to create an app, but if the app's feature is general, maybe that's not what you want to spend time on. Maybe there's an off-the-shelf version for something like that. And really what you care about is paying attention to what features you're extracting from the reading, et cetera.
Yeah, I completely agree with you that there probably is overlap with other conditions in terms of what speech variables would predict altered mental status. I will say that winner-like group that I mentioned from the start, their focus is Alzheimer's and Parkinson's. And we've compared the variables that are significant in my analysis to theirs. And there's, it's kind of like a Venn diagram. Like there are some that overlap, but there are some that are unique to each of our disease states. But yeah, I think it would be interesting to have a kind of one size fits all tool that would be useful for multiple different disease states. That's a really interesting point.
Because I think the general assessment may or may not be broadly applicable, but my sense is that it probably is. But what you extract from it, what you're paying attention to, what you throw into an algorithm may not be. And it sounds like there's probably, some unique and some specific. Yeah. The other thought I had, and this is you probably already thought of this, so you can tell me thanks, but already thought of that. It's just that there's, when you're modeling long-term cognitive assessments, and particularly sort of full neuropsychiatric batteries, when you're looking at things like dementia assessments over the long term, they have both practice effects as well as long-term deterioration effects. And so I think you want to, if one of the things that you're generating are paragraphs that people have to read, then you either would want to have the ability to account for how many times they've been presented with a paragraph to read before, versus how many times it's the same stimuli, or maybe you want to generate what in psychometrics is referred to as parallel forms, right? Where there's going to be paragraphs that have similar features, maybe similar length, similar complexity of words, similar sentence structure, or something like that, that could be treated as essentially fungible or parallel, and at least you're varying what they've been presented with before, so that you're not having to deal so much with practice effects. But the broader point is dealing with practice effects.
Got it. Yes. We did that for the picture description task. It was different pictures each time, but not for the paragraph. It was the same paragraph each time. And now that the paragraph reading actually ended up being the most useful speech task, I agree with you. I think I probably need to deal with the learning effect.
Anyway, those are, thanks for the interesting presentation, and those are my thoughts.
Awesome. Thanks, Aiden. I see Sarah raised her hand too.
Yes. Hi. I haven't had a chance to meet you yet, but I'm one of Emily Maurer Provost's close collaborators. So I'm on our new R01 using use speech to detect mood and bipolar disorder. So thanks for the shout out
Oh
about
yeah.
those projects. And so one of my questions was I was thinking about what you were talking about with the idea of, you know, a website or baked into Epic or different things. And I'm just curious in the condition that you're studying, I'm going to call it HE because I don't want to butcher the name of it. Like how fast do you anticipate these changes happen? Like, is it important to be detecting it, you know, in the moment as people are going about their normal daily lives, like we need to in bipolar disorder? Or do you think it can be more circumscribed to clinical visits or touch points? What are you thinking about that in terms of its like generalizability and usability in like the real world versus in clinical settings?
Yeah, Sarah, that's such a good question, especially in this disease because, and I didn't get into this in too much detail in the background, but people with HE, I'd say the most common presentation is that it's sort of smoldering. So you start to develop it, and then over the course of months it kind of gradually gets worse and then kind of climaxes in this really severe event where you end up having to get hospitalized. But I see two of my nurses are on this call too, and they know as well as anyone that it can also just come out of the blue. Like it can just, you can be normal, you think one day, and then the next day, boom, you're in an episode. Or more likely over the course of a few days, but still, it can be pretty fast. So I really worry about that latter scenario. How much am I going to really be able to do for those folks who just have the really rapid changes? Thankfully, for most people, I do think it's that smoldering gradual where I'd have time to react, or, me being any of the providers would have time to react. I will say in this study where I was showing you how we were able to predict over at HE, most of the events, we were predicting them within about 30 days of being recorded. So it didn't have to be like the week before. We were seeing an effect even when it was 30, 35 days out. So I think sorry, that's a long answer to your question, but basically saying, I think it couldn't wait to be just during visits, like every 6 months, but it might be enough to do it once a month, which then maybe isn't so terribly annoying. And it's actually feasible to get people to do something once a month. Maybe even better would be once a week. I'm not sure. Like these are some of the implementation things that I don't really know how often I'm going to need them to record.
Yeah, I think, you know, one of the interesting things to think about, and we certainly see this in the priority data, is there can be these speech features that, you know, in your model predict something. Um, but one of the questions is like, is there some ultimate threshold at which these things signal something's wrong, or is that unique to the individual? So like, is it a between person threshold, or is it really focused identifying a change in that person relative to their state before? And if it's that case, then I think as much sampling as possible would really be important. But if it's this more between subject model that's predicting this threshold, then yeah, you might as well make it as infrequent as possible so that, you know, it's not burdensome to people.
Barry,
But
you're reading my mind. Yeah, yeah. I ditto. I
yeah,
wonder about this as well.
yeah, yeah. Great food for thought. Thank you for your presentation.
Anson, I see you raising your hand.
Hey, how's it going? Great presentation. This is really interesting work, and it's cool to see how there's both sort of independent ways of going about this, and then some of these sort of ready-made applications like you utilized as well. I was just thinking about, I'm a neuropsychologist in psychiatry. I was just thinking about the practice effects issues and something that I'm working on right now as well in this space. One idea is to leverage some of the large language models for generating paragraphs. So
Mhm.
you actually provide the same semantic difficulty, and you can modify vectors of the generation of the paragraph such that it's the same difficulty, number of content pieces, things like that. So then they're getting a fresh story every single time. And there's basically infinite possibilities for that. So you can plug in an API from GPT or some other large language model to do that. Something we're working on. But otherwise, the speech stuff is awesome. And I'm more in the dementia, Parkinson's, mild cognitive impairment space. And I think brief interventions that you can really track the intra-individual variability is sort of coming into play a lot more now than the traditional sort of large normative sample model in a lot of ways, especially with some of these technologies. So something to keep your eye on. I think you're right with keeping it brief and thinking of accessibility above everything else as we try to capitalize on this. But thanks for the great presentation. Really awesome.
Thank you for those comments.
We are almost at time. Do you need to get off right at 1:30, Patty?
Pretty much, yep.
Okay.
Yeah.
Okay.
I'm in the procedure unit today, so they'll
Okay.
start paging me if I'm not down there soon.
So why don't we end there then? And I just want to thank you. This was really fascinating and exciting to hear the conversation as well. And just thank you for your time.